Good morning, students. I hope everything is well, and I'm so glad you clicked on this video. So, in this video, we are going to act like you just walked into chemistry on day one of your chemistry class. Now, this video is going to cover the first lesson that we're going to teach you, whether it's for test review, whether it's to study at your own pace, or whatever it may be. This video is perfect to set up the foundations for chemistry. So, let us begin. What is chemistry? Well, chemistry is the study of matter, and as I like to say, and you will probably see quite soon, chemistry is mainly the study of electrons and how they react with each other. Now, what are standard measurements? Standard measurements are kelvins, kilometers, meters, grams, all of that are standard measurements that scientists have declared as the normal measurements to post research, so everyone knows what it is. For example, instead of Celsius or Fahrenheit, we use kelvins, so everyone knows, hey, we're using kelvins, and it's not a miscommunication error. So that's what standard measurements are. Now, one thing to note is you might be given metric prefixes, such as tera, giga, mega, kilo, hecta, deca, base, deci, centi, milli, micro, nano, pico. Now, you don't have to memorize, you have to memorize this, but you don't have to memorize it like that. That is insane, and absolutely not. So, the other way I like to do it is the great mighty King Henry, or tera, giga, mega, kilo, hecto, died, deca, by drinking chocolate milk, base, deci, centi, milk, milla, mixed, micro, in, you don't need to know in, it's just to make the acronym more sense. Nasty poison. And you will most likely use conversion factors to change from metric prefixes like 1 kilometer to meters, or 207 millimeters to 1 meter, and it may also be from metric to customary, like 3 miles converted to 1 kilometer, but these conversions are also known as dimensional analysis. And when you do dimensional analysis, you must obey to the rules of sig figs. Now, there's 4 rules for sig figs, and we're going to go over all of them. So, all non-zeros are significant. 1, 3, 5, 6. All of those are examples of non-zero. Non-zeros also include 7, 8, 9, all of that. Now, zeros between non-zero digits are significant. So 1, 0, 0, 2 means that these two are significant. 4, 0, 5 means that this 0 is significant, but 4, 5, 0 does not mean that this 0 is significant. So for that one, it means that it only has 2 sig figs. Now, leading zeros are not significant. So 0.00351 has 3 sig figs because these zeros here are not significant. And 0.00027 only has 2 sig figs, again, because these zeros right here are not significant. Now, trailing zeros at the end are not significant unless there's a decimal point. So that means 2700 decimal point has 4 sig figs, but 3800, no decimal point, only has 2 sig figs. The difference is one has the decimal point. Next, we're going to go over density. Density equals mass over volume. Now, if this formula is a little confusing, or you're not trying to find density, that's why we have this little density house right here. You plug in, you take out what you're looking for. So let's say I'm looking for mass. I cross out mass, cover it up, and I get density times volume. Or let's say I'm looking for volume, I get mass over density. Or let's say I'm looking for density, like this normal equation, it's mass over volume. And that's why this little triangle house is an absolute must-know, because it is a lifesaver. Now we're going to quickly go over scientific notation. Scientific notation must be between 1 and 9. It cannot be 0, and it cannot be 10. So 1,000, 1 times 10 to the third, 2.02 times 10 to the third, 42,342. So 1,000, let's look at the first number, that's the first digit. It's a 1. So that right there will be our base. Now, do we have any other significant numbers? Not that we see right now. So we don't need to put anything. So we put 10 times 10, and then we count our zeros. 1, 2, 3. You can also count your digits as well. So times 10 to the third will be our correct answer. And now let's check it. So 1 times 10 to the third means we'll move it 3 times. 1, 10, 2, 100, 3, 1,000. So that means 1,000 is 1 times 10 to the third. You can try these two on your own, but this was just a quick, simple explanation of significant figures because I already assume you know about significant figures. I mean, scientific notation. Now, matter. Stages of matter are solid, liquid, and gas. Now, you don't really need to know this. This is kind of normal information from previous years in school. So solid, close together, movements packed in place. Liquid, particles that are spread out but still close, they often hit each other. And gas, particles spread apart, move freely, Now, physical properties. Properties that can be measured or obtained without changing the chemical structure. And then there's chemical properties. Properties that can be observed only by changing the chemical structure. Okay, students, let's continue. We are going to have some practice problem here. Pause them now and try them on your own. I'm not going to show them again. I'll say them out loud, but it's a little difficult for me to come down here to my notes and write the equation and stuff and solve it. So just look at them now, try and solve it on your own, and we'll come back at the beginning of each problem and that at the end of the problem, but I won't keep it up while doing the problem. Okay? So anyways, let us continue. For the first equation, we have converting 272 meters to micrometers. So this is quite simple. So earlier, we talked about the prefixes for the metric system. So we have 272 meters, and we got to convert that to micrometers. So we have meters on top, so we got to put meters on the bottom, and then not mm, because there's already mega and milli. So the bigger unit gets the 1. So meters gets the 1, and then to get to 1 meter is equal to 10,000 micrometers. So then that's 2,720,000 micrometers. And that is your final problem, and that is how you solve problem 1. And now this is the conversion factor we talked about, and then you just put the amount of zeros it is away. So like I know in the metric unit, the metric table I showed you, it was 0.0001 01 for micrometers, but you can just take these 5 zeros here at 4 zeros, and put it here at the end of the 1, and then you get the 10,000. So you don't have to put 0.0001. That's another way you could do it. However, though, 0.0001 to 0.0001 on the bottom, and you put 1 on top for millimeters and meters, because 1 micrometer is equal to 0.00001 meters. Now the next equation, it asks us to convert 1 year to hours. Now this requires a few more conversion factors, and so 1 year to hour. So 1 year goes on top, then we got to put year on the bottom, and we're going to do day on top. So this is the conversion from times, because we know how many days there are in a year, and we know how many hours there are in a day. So our conversion factor is going to be set up like this, and we'll get hours eventually because we cancel out the units. However, first let's just solve the equation. And year is bigger, so it gets the 1, and then there's 24 days in 365 days in a year. Then there's 24 hours in a day, and day is bigger than hours, so it's going to get the 1. And then we just multiply that, and we get 8,760 hours in a year. Now, let's determine the sig figs. So this one, I don't think we must, but remember, we must not write, for this one, I don't think we need to write it down, but either way, I will to help you visualize it. So we have 202, and then we want to know how many sig figs there are. So we have 2 non-zero digits, but then we have a 0 in between this, so that means there's 3 sig figs. Then we have 100 without a decimal point, and since there's no decimal point, it's a 1. But if it was a decimal point, it would be 3 sig figs. Then 0.00052, and then that only has 2 sig figs because this is not significant. Remember, leading zeros are not significant. So 2 sig figs. Then lastly, we have 3,000 with a decimal point, and that gets us 4 sig figs. And then lastly, we have some density problems right here. Now these ones are a little bit tough and tricky, but we will go over them, so not to worry about that. So we have 1.50 grams over milliliters as our density. Then we have, remember the house, guys, mass over density and volume. So we gotta cover up mass, so it will be density times volume. But first, let's just set it up how we normally will. Top, and then we have a volume of 3.5 liters. And we can't do that because this asks for milliliters right here. So we have to convert that liters first. So 3.5 liters, and we gotta go to milliliters. So liters on the bottom and milliliters on top, and then liters gets the one because it's a bigger unit, and then milliliters is 1,000. So we get 3,500 milliliters in 3.5 liters. So then we're going to do our house again. Density times volume, or 1.50 grams over milliliters, times 3,500 milliliters. Now, because this is over milliliters, this is just saying that this is over milliliters. We cancel out the milliliters, and then we get grams. So that would be 1.5 times 3,500 is 5,250 grams in is the volume. And then lastly, we have if a solid weighs 84 grams and occupies 30 centimeters cubed, what is the density? And that is a little tricky if you don't pay attention to the centimeters. So centimeters cubed is basically volume, because if we think about it, volume is length times width times height. So length times width times height, and then that's cubic meters cubed. So it's a solid, so of course it's going to be 30 centimeters cubed. So that's just a little way to think about it, so don't even worry about the centimeters cubed. Okay, so 84 grams, that's our mass, and then we have 30.0 centimeters cubed equals our density. Equals our volume. I apologize. Equals our volume. Then we just got to put it in. Remember the house again? density and volume, cover up density, mass over volume. So 84 over 30, and we get 2.8 grams over centimeters cubed. You just put centimeters cubed. You don't put liters, you don't put milliliters. And those are the practice problems. I hope this is helpful, and I hope you learned something out of them. And here is the practice problems for you to look back on if you have any questions.